Okay, let me share my screen. Okay, let's look at this example. So it's a sprinkler head example. Also, one of the popular example when people study about fluid mechanics or control volume analysis. So yeah, so just pay a bit more attention to how we solve this kind of question. So what we're having here, if you look at the diagram here, we're having a sprinkler head, and this sprinkler head is usually you can find in the garden, where the farmers or the gardener will switch on the machine, and then the water will go in from below, and water will spray from both ends. Some of it only have one end, but normally they will have two or maybe four. Okay, two or maybe four. So the question give you, you have a rotating sprinkler. The base is steady. At base, through base, you have a steady rate of 1000 ml. In this case, is ml. All right, per second. So you have a 1000 ml per second at the base here. So you're seeing the word steady here. So it help you to solve your equation. The acid area sketched in both nozzle is 30 mm per second. 30 mm square. As you can see on the diagram and on your screen, is labeled in 30 mm square. Of course, in test, we won't be that kind to do this kind of labeling for you. You need to know what is the meaning from the statement, question statement here. Okay. Of course, in exam, you won't see the W. Yeah. Okay. All right. What we need to find from this setup is that we need to determine the average speed. You see the word average speed here. So average speed also normally it will link with the moving control volume kind of question. So average speed of water leaving nozzle relative to nozzle if we have three scenarios here. So what happened to the average speed if your head, sprinkler head here, this is your sprinkler head, doesn't move. Okay, meaning that this sprinkler head was this L shape kind of elbow here. The whole thing doesn't move. Then you only look at the water. So what is the average speed of the water if this thing doesn't move? Okay, if this thing doesn't move. The second one will be, after you solve for the first scenario where it doesn't move, you look for the second scenario B, where the sprinkler head rotate at 600 RPM, round per minute, or revolution per minute. So meaning this sprinkler head, as you can logic thinking from the diagram here, if you spray from this area, the water will come out like that. So the head will rotate anti-clockwise if you view from the top. Okay. So you rotate like that. So you rotate at 600 RPM. What will happen to your W? Okay, average speed here. What is your W2? The third scenario is that what happens if you accelerate? Okay, you want to look at the average speed, the changes of average speed from 0 to 600 RPM. What happened to your W2? Okay, we have three scenarios to solve. We'll look at the first one, where your station, your head doesn't move, or your the head doesn't move here. Okay, all right. So for your info, in test, normally the first thing we are looking at is your control volume. Make sure you draw something, you sketch something in your answer, and then you copy the shape of the interest of that particular item. Okay, you draw the shape of that item, you label as CV, you get 1 mark for control volume point. Okay, let's solve. So I pull the diagram on the top right corner. Okay. And we solve for the sprinkler head is not moving case. First, by standard, write the conservation of mass equation or continuity equation straight away equals 0. Okay, again, conservation of mass doesn't equal 0. But when you mention continuity equation, then only you can write equal 0. Okay, be sensitive to the name of the equation that you use. If you mention continuity, means the control volume plus control surface equals 0. If you only mention conservation of mass equation, then the equation not necessarily equals 0. You need to write the del or the m dot system equal to control volume plus the control surface. So this is the differences between conservation of mass equation and continuity equation. So again, flip back to the first lecture that we did, then you will understand what we are talking about. Okay. So again, we're having a steady flow, so we cancel the control volume entity. Then you draw the green arrow to the CV component. You write equals 0 equals steady, you get 1 mark for steady flow definition. Then you only focus on what is happening to the control surface here. So control surface here, remember to use the sketching to help you, where you need to look at the input, output, and then draw the surfaces. Look for the velocity. In this case, we look for W velocity and look for the opening of that things, for example. Okay. W might going in or going out, depend on the diagram. Okay. Now, for example, here, if we draw the diagram for this section, then W will spray out. So your W will point out. Area will point out also, because area always pointing out. Same arrow, get positive. Different arrow, get negative. Okay. So I move a little bit faster. So we only focus on control surfaces. Rho W. Again, if you write V in this question, straight away you lose the mark for equation. If you write W, then you will score marks for this one. Okay. Yeah. So be careful. Look carefully whether the question is moving control volume or is stationary or fixed control volume. Be careful on the notation that you use. So the next one is just to analyze whether it's positive, negative for your m dot. You look at the diagram. Where is your input? Where is your output? So you have section 1, section 2, and section 3 in the diagram. So in the diagram, you have section 1, which is at the center here, the inlet. Section 2 is here, outlet. Section 3, outlet. So that's why you have row A, W. We use W because we have a moving control volume. Plus row AV, W, 2, refer to section 2. Row AW, 3, refer to section 3. And by now, you should know why the first one is negative, why second one positive, why third one positive. Okay, take note on the notation. You derive this equation from the second equation you see on the screen here. This one 1 mark, this one 1 mark. Sometimes I will give you more marks for the derivation equation. Sometimes this one will go up to 2 to 3 marks. But minimum, there will be 1 mark. Okay, just for your info. Then, since in the question, there are some hidden information. If you look at the question is deal with water. Okay, you deal with water. So normally water, you can write, since water is used in the system, then you write compressible. You can write since water is used in the system, or water is used in the system, assume incompressible fluid, then you write rho is the same. Then this one give you 1 mark. For this one is the hidden message inside the question. So if you look at water, if they're using water, then you can straight away assume incompressible fluid. Then the equation that you see on the screen here, you can cancel all the rho inside the equation. Before you cancel, you make sure you write this statement. Before you go and cancel anything in your answer, in your equation, make sure you explain why do you cancel. Don't cancel, then you assume me understand what you're doing. Okay? Because your answer will always double check by other markers or other lecturers. Okay, so that lecturer might not be teaching this module, but he have to be understand why I give you marks at a certain level. Okay, so there's a mark for that. If you cancel without explaining, then I cannot give you mark for canceling. Okay, just explain and let you know how we mark your paper. So at the end, the equation from this one, the last equation here, with the red arrow, I cancel out because of water, compressible, rho same. We arrive at the one that on this screen here, minus area 1, relative velocity W1 plus AW2, AW3 equals 0. So again, when you look at area times velocity, you get Q. This is the question that I asked the class the first session, right? So Ku and Dinesh, I already asked you this kind of question already. Don't make this mistake in your coming test or exam. So try to look for Q, or volume flow rate, when you have A times velocity. Right, so this is a relative velocity, so you still get Q. All right. So I make some note there. Area 2 equal to area 3 is the same. W2 will equal to W3. Why I write the green color here? Because I can simplify my equation on the top here. Because when I equal A2 equal to A3, W2 equal to W3, I can further simplify my equation. Of course, you can continue to substitute the same number 2 times, but it will help you when you can able to do simplification. So I can write my minus Q equal minus Q plus 2A W2, because 2 and 3 is the same, so I just double the magnitude. Then I rewrite what is my W2 in the formula form. W2 equal to Q divided by 2A. The next is just substitution of value. Okay, so again, I write some notes on the screen here. I just show you in tutorial question, I show you how to build the equation. The rest is your work. The rest is just substitution of numbers and your use of your calculator to show the calculation. All right, so you will get answer. This is the reference answer for you when you do your revision. W2, your relative velocity will equal to 16.7 meter per second. So for this module, especially when it comes to your 3rd year or 4th year module, always apply 3 decimal place if you can. 3 decimal place. Okay, this is a tutorial question, so I will simplify most of the thing. So just let you know. So once we get the W2 for A, W2 is 16.7 for rotary. For the head is stationary, which doesn't move. So you get W2. Then for B and C, what happened? So just take note, the value of W2, which is W2 is the relative value. is a relative value, like you comparing something to someone, all right? So let's say two person are running. Okay, two person are running. Again, apologize for my drawing. A and B. So if you talk about the relative, the differences between A and B, the speed of running between A and B. If you talk about the relative, so I use the W as a relative. Relative speed between A and B will always same. Okay, no matter how far you stand. Okay, so back to the statement that you see on the screen here. Just to take a note, so W relative is independent of the speed of rotation. It doesn't matter whether your spring head is moving or not. The W2 that spray out from the area will always same. W2 is relative velocity. If you talk about velocity spray from the head, maybe it might different. Okay, but however, for section B and C, I put a special note on the screen here where I highlight with the red color text here, means that it doesn't affect by the rotation. Okay, W2 is a relative value, so that is independent, meaning it doesn't change whether you move or what is the speed of the control volume is spinning. W2 are always same. Okay. So answer for B and C is the same as A. So if this kind of question come out in test or exam, B and C, actually you need to explain why you use A answer. Why do you use W2 equal to 16.7 meter per second? You need to explain. Because W2 is independent of the speed of rotation. It's a relative value. Okay, you need to explain. You need to know how to explain. Just to take note, however, if you want to find a V2, then it will be different because of the rotation speed, omega. Okay, I put some note here because you still recall that we learned about the vector equation just now. We have V equal to W minus U, or the control volume speed. So you need to be careful. W doesn't change to the rotation. However, V will change because your U, okay, your U, this component is given by equation because of the rotation speed, U equal to omega R. So this one you learn in your machine module, or you learn in your static or dynamic class. Okay, when you have a rotational body, you need to link your omega with the radius, then your U will link with the products of omega times R, then you get the velocity. Okay, so velocity and the velocity and relative velocity is a different things. So this one you need to refer back to the triangular vector that we learned early session today. Okay, look back at the slide there. Okay, let me stop the recording.